Alright, so today we're going to be explaining resistivity. So, the first thing you need to know is that resistance is equal to the resistivity constant of whatever material you're using times the length of the material that you're using, or the resistor, and that's all divided by the cross-sectional area of the resistor wherever you're measuring it. And that should be a constant. And so in this lab that we're going to be doing, you're going to be recording the values for the voltage across the resistor that you have and the current across the resistor, because the resistance is equal to the voltage over the current. All right? So eventually you're going to be graphing the resistance, or the length versus the resistance, which is voltage over current. So to do this lab, you're going to be changing the length of the resistor, which is effectively just a wire. You can clamp down this, and that will make it a 10 centimeter long resistor. So that's the length you'd record. And then you change the distance, so you can make it 20, then go to 30 centimeters, and so on. Then you record that, and you put it on a graph, and you're going to want to put that on the horizontal axis. Next, you're going to want to record the voltage over the current, which is the resistance, and you put that on the vertical axis. And this should give you a linear slope, and so a linear graph. So the slope of this linear graph is going to be the resistivity over the area. And as long as you know the area, you could get the resistivity of whatever material you're trying to get the resistivity of. Now, one thing I should mention is that the ammeter and the voltmeter, the ammeter should be in series with the resistor, and the voltmeter should be in parallel with the resistor. And so finally, I guess we could go through a whole trial run of it. So first what you want to do is turn on your power supply or connect your battery to whatever it is that you're doing. Turn up the voltage to say 4.5 volts. Now what we're going to do is we're going to go to a specific length, whatever you want. Let's say 10 centimeters. All right, you're going to record the current and the voltage that result, and you're going to record the length. Then from there, you repeat the process with different lengths, and then you graph that stuff, you graph that data, and from there you can find the resistivity of any material. And finally, there are some common misconceptions with this lab. First, the ammeter has to be hooked up in series with the circuit, and with the resistor, and the voltmeter has to be hooked up in parallel with the resistor. Otherwise, they won't get the right readings whenever you connect to the power supply and turn it on. And another misconception is that the slope of the graph that you get is the resistivity over the cross-sectional area of the resistor. So to get the resistivity of the material, you have to multiply that slope by the area. So if you know the area, you can find the resistivity. And the last common misconception is when you are taking the measurements, you have to make sure you're taking the measurements of the ammeter and the voltmeter, and not from the power supply if you're using a power supply. Otherwise, you'll get wrong measurements.